tomorrow and next tomorrow. So, and also we have an in-person event on Saturday. So for some of you guys who are in Lagos, this is an opportunity to like get your hands, busy. Uh, we have some prizes from the Graph, one of our sponsors, and also our host, University of Lagos. So it will be a very special moment. Um, just a minute, I'll now share my screen. Uh, quite hanging a little bit. So, okay. Okay, so while I resolve these technical issues, um, yeah, yeah, just let me just ask one or two questions. I can still my remarks. Hi, Josh. Let's just do some self-intro. Let's get some, especially as much. Let's know what's up with you, how it's going with your studies after the boot camp. Let's get to meet everyone. Uh, I need to resolve my slide first. So, who is going first?
Okay, of course, while we wait for our speaker to fix his technical issue, like he said, it would be nice, of course, to get to meet us, of course, know what you've been up to. Osinachi.
While I resolve these technical issues, uh,
Okay, thank you. I don't know if you can hear me clearly.
yes, I can hear you.
Okay, as my name says, I'm Osinachi. I was part of the last concluded bootcamp 2023/2024. Personally, I have interest in anything that has to do with blockchain and specifically smart contract auditing. So I really hope to engage in the whole starting of the abstraction idea and how to really interact with the ecosystem of the Ethereum ecosystem as a whole. So I look forward to learning a lot just these few days. Thank you.
All right, that's awesome. Nice to meet you, Sinachi. Of course, we are happy that, of course, you're growing along in the blockchain ecosystem. It's so nice to have you. I saw Max a minute, but I think Max is gone. Okay, George. Hi, George. Nice to meet you. Can we meet you, George? Can you hear us?
Yeah, I can.
Okay, nice to meet you. What's up with you? Let's hear from you.
Okay, I was among the Eton, the one that was just telling you that I'm Benjamin Ugajosa. So I attended the event. I was part of people that attended the event that went, that just was it the one that just passed in so I just wanted to follow up. I saw the I saw the link on my Gmail. I was invited for this, so I want to learn and be amongst people that understand and follow up on account abstraction. I'm not that good in developing, and yeah, so I just feel that this is an opportunity I shouldn't miss. Can you hear me?
Yes, we can hear you.
Okay, so that'll be all about. So I just want to be among people that participate in this. So thank you.
It's great to meet you, George. And of course, we believe and we hope that at the end of this series, of course, we will all be familiar with the concept of account abstraction and, of course, improve our skill and how to deploy and use these in decentralized applications. Yes, Max, nice to meet you, Max. Hi.
Good evening to you, sir.
Good evening. Can we meet you?
So my name is Osho Samuel. I was around at the last boot camp that took place at Unilag. So basically, in general, I'm enthusiastic about blockchain development. I've been going through the EPF study group that was dropped on the Discord and Telegram. So I've been learning about Ethereum for a while. I'm not so conversant with blockchain, but I've been able to play around some source codes from GitHub and deploy contracts and deploy tokens on the blockchain. So I'm looking towards having a wider knowledge and contributing to the Ethereum Nigeria team.
Yeah, that's awesome. Of course, you're always welcome, and we are of course always here to provide the guidance and mentorship, and of course provide resources to push you ahead. Of course, Mr. Simeon, yeah, I think I am very familiar with you, but of course, you can hear us. Please let's meet you, Mr. Simeon.
All right. Good evening, everyone.
Good evening, Mr. Simeon. Yes, loud and clear.
Yeah, great. My name is Simeon Nofa, and I'm a blockchain enthusiast and also a DeFi participant, just like everybody else. My major interest is decentralized finance, anything that has to do with finance within the blockchain space. Just call me, and I'm always there. So I'm also a major contributor to the Ethereum Nigeria community, as well as the strategies at Ethereum Nigeria community. So I do a lot of projects on DeFi, Web3, most especially finance and fintech projects here and there. So basically, I'm open to. I'm always involved in any of our activities and projects just to show my enthusiasm and interest as well. Thank you very much, Tete. Thank you for the team. Thank you for putting this on. Thank you, guys.
That's wonderful. Nice to meet you, Simeon. Of course, he's also he possesses a wealth of knowledge. Also, of course. Nice to meet you, Dean. Hi, Dean. Can you hear us?
Yes, sir. I can hear you. Good evening.
Good evening, Dean. Yeah, welcome. Can we meet you? Just a brief intro of yourself, what you are up to at the moment.
All right. My name is Dean Hidoko, and so far so good. I am a tech enthusiast and with a background in the applied sciences. And my career has been majorly in sales development. So I'm currently the sales manager at Sabine Consulting, a tech innovation lab in Abuja. So why I'm here is to upskill because I know that there is a applicable knowledge available to be obtained here from the boot camp that we did. So the boot camp is just like icing on the cake. So I want to become a baker, get the ingredients and bake for myself. Thank you so much.
Of course, yeah, you're welcome. And of course, on your road to being a baker, like you said, I believe you are in the right path with Ethereum Nigeria. Of course, we are here to make sure that happens for you. And of course, my name is Etete Etok. I'm a software engineer. I'm also a blockchain developer. I'm currently CTO for Ethereum Nigeria. And of course, it's nice to have you guys here. Yes, So that's me. And back to our speaker. We believe technical issue is resolved. So please, sir, if you can hear us, the floor is yours.
Hey guys, it's can you hear me? Hello?
Yes,
Yes,
sir,
we
we
can.
can hear you.
Okay guys, okay, it's really wonderful connecting and meeting some of us who were together earlier. So greatly, as I said, it's going to be in series that virtually. So we have today, tomorrow, and next tomorrow. So like a hands-on. Today we're just going to just introduce you basically for those who are just coming in. Just some little intro to smart contract, how to deploy. And then tomorrow we'll do some hands-on. Next tomorrow, hands-on. And then on Saturday, as I said, we just have some just there's some prizes for you guys to win and stuff like that. So happy workshop. All right. To the next slide. So this is actually kind of a road build up to one of the events we'll be having. We hope to have like a couple of events this year called the Eat Lagos. So we'll be having a couple of workshops in Lagos and then as well in other locations. Deploying smart contract on Ethereum. So based on the introduction, I'm really impressed. At least we have so many of us who are like pushing some stuff to the networks. So so this is just basically a refresher for you. It's actually for the beginners as well, who haven't or who will be starting from today or tomorrow thereabout. So what are the consideration on best practices in deploying a smart contract? One of those things. So basically, this course is actually an overview of and all the kind of like consideration in deploying a successful application. So smart contract, let me even start. What are smart contracts? So one of the definitions we're able to like outline here is smart contract are self-executing contract where the terms of agreement are directly written into code. So it's a digital contract run on the blockchain technology, enabling automated and trustless execution of predefined conditions without the need of intermediaries. Smart contracts facilitate, verify, and enforce the negotiation or performance of an agreement, providing a decentralized and secure way to transact without any party. So this is just like a code written, perform this function. If this is met, they execute. If not, return. So and that has been the technology there. So if this agreement meets, give us the result. If not, checkmate. So it's been one of the coolest technology on the Ethereum space, and so many virtual machines are springing forth, exploring on this application. So you have a lot of smart contracts that are interoperability. That is from one blockchain you're connecting to another one, and it's so beautiful. And that's also leads us to also tell you about what we're also pulling out. We're pulling out some stuff from you guys. You guys will be hearing from our groups. So as you all know, in the last boot camp, this one of the characteristics of a smart contract is immutable. What's immutable? Once it is deployed on the blockchain, the smart contracts are immutable. It can't be, altered, meaning that the code can be altered, can be tampered with. The characteristics ensures the integrity and the permanence of the contract logic and rules. So this can be altered. And remember, once it's deployed on the blockchain, a copy of that your product application or dApps, your application is reciprocated as in it's replicated in different nodes. And you can imagine if you want to alter one, that means you need to like meet like a 60-70% consensus, which is very, very ridiculous. So that's the beauty about technology. And so happy the government, a lot of stakeholders are embracing this technology, So when we even had our event in Unilag, The officials were like so excited and still want to see how we could educate them more on this technology. So that's how powerful this ecosystem is thriving. So transparency, we were looking at something that is transparent. This is the space. So smart contracts operate on a transparent and open ledger. As you all know, and this is what you learned in the bootcamp, it's typically in a blockchain. Every transaction execution is recorded and visible. Once you have my wallet, you can even see, you can just see my history on how I transact. So that's the beauty about it, participant. So this transparency encourages trust and accountability. Mind you, we also have a private blockchain. So this is where all these some big stakeholders come in and they don't want their stuff to be on public. So we have a private blockchain. So but all these things are still written on, special smart contract codes. All right, you're familiar with this characteristics. It's trustless. It says in terms of execution. So so how is it trustless? It does not rely on any centralized authorities. So that's the beauty. Remember what you learned in the bootcamp. For some of you who participated in the bootcamp, it is without any intermediary. It is, so the rules and logic are encoded on the contract govern the execution, and it provides this reliable and secure way of carrying out transactions. So everything has been coded. This is the rules governing this, So that's to tell you that's also to remind you also each blockchain, each protocols has their own rules that govern the network, and that's what makes it. That's what bring out the beauty in the whole ecosystem. For the Ethereum, you have a protocols that governs this the ecosystems. And I'm so happy someone said he's already in the study group and also exploring it. So you understand what I'm saying, and through that you'll be familiar with so many Ethereum improvement EIP versions, different. So decentralized storage, decentralized consensus. It is the smart contracts who leverage on this. It leverage on decentralized consensus mechanism blockchain networks. One, the transaction are validated and agreed upon by network participants. So if you also want, this is something that you can also be a part of the network participants. It's actually open. Once you meet up, you're able to meet up some protocols, the rules that is assigned or the criteria for that. So it eliminates the need of a central authority to validate or maintain the contract terms. So that's one of the characteristics of smart contract. In terms of automated execution, smart contract execute automatically. As I said, once a predefined condition is met, and once the specified contract codes are met, the automation reduces the need for any intervention. It minimizes risk, errors, disputes, So that's just the beauty about this. And it is self-executing. So as a self-executing agreement, smart contract automatically enforce and execute the terms without the need of external intervention. So it has really taken off third party seriously. So the feature is streamlined, the processes, it reduces cost, and it ensures timely execution of agreement. In terms of digital programmable, they are digital and they are programmable entities. So it allows complex business logic and conditional statements once it's met. Developers, if you're a developer, the beauty about this business is, so that's why we are we've done the intro and we want to have more developers in the ecosystem, as in the community as well. There's so many stuff happening, so many stuff where the developers, can leverage in. Developers can code intricates and functionality into the contract, making them adaptable to a wide range of use cases. So that's why we want to raise this year. We want to see how we can get more developers in the ecosystem. So there was a document I shared, I think internally, in terms of Web3 generally, and we discovered that Ethereum is really doing great in terms of developers' contribution to the ecosystem. So let's just keep it up, and you that have make out time to join these phases, just be ready and then just follow up on, with every whole stuff. All right. So one of the languages for Ethereum smart contract development in Ethereum is Solidity. It's a high level statistical type programming language designed for developing smart contract on Ethereum blockchain. So that's to tell me, if you're very good with JavaScript, then it will be very, you can easily hook into this. So I would just encourage you to like brush up your JavaScript and then come in. So what's the primary use of Solidity? It's mostly widely used for the Ethereum smart contract due to its compatibility with the EVM. Yep. All right. So this is like the code itself. This is like how to declare a contract, you know. So every contract on the Solidity, you know, has a version. So if you're working on this version, you just have to be consistent with this version. You can't work on this version and then happen to like come to version 9 or 10. No, if you're working on Solidity, you know, version 8, then you have to stick to that in terms of the whatever you're building up. So this is something you need to be familiar. So this is declaration of a smart contract. You have the private Solidity version. You see the version declaration, and then you see your contract. You see your smart contract. Then here goes the logic. This is that's the contract. That's where you write your logics there. A snippet of how it looks like. This is what you'll be seeing from tomorrow and next tomorrow and Saturday. So we expect you to be familiar. So you're declaring the smart contracts. You're also familiar with the variables, you know. So Solidity support various data types of variables, including the UN int, the unsigned integers and the signed integers, the boolean, and many more. So it all depends on whatever you're declaring. So this is just how the variables look like. So it's public, it's actually open, can be accessed by anyone. And so these are like the function and the variable. So this is how it looks like. The next one is the function, and this is how the functions look like. So function in Solidity can be declared with visibility modifiers. So you have the public, you have the external, you have the internal, you have the private. So you can have a function where you want just few people to have access with a private function, and you can have a public function. You can, where you have a function, and you know, anywhere you can call up the codes, and you can as well. It all depends on how you define your function. So this is how it looks like roughly. Your function add, you have your declared integers, and then it's a public or private, and you know, you move on. So for the event I used to log and broadcast information about specific occurrence within the contract. So you need to be familiar with your event log. So sometimes when you build your stuff, and you can as well read your applications going through the logs. So this is how the event logs look like on the Solidity. So the modifiers as well. Modifiers are used to customize the behavior of functions. They can ensure conditions before executing. So the modifiers, this is how the modifier looks like on the code, is how it looks like. Start with the modifier and then you move, you know, so you can restrict it and make it open as well. So your logic comes in here after the function. All right, that's your data structure. If you if you're a software engineer and you're very good with data structure, this is very important. You know, data structure is very broad on its own. If you're very good with data structure, very good. So you can, instead of writing a long code, because you're very conversant with data structure, you can write a simple one-line code doing a lot. So and this is where you can express yourself. So Solidity support data structures like struct, allowing the developers to define. So this is the beauty about Solidity. So I'm speaking from the software engineer. If you're familiar with this data, well, maybe I think we also make our time to have this session, data structure. It's something that maybe like a brush for people who have just like a brush, but it's a very beautiful course. And I remembered when I started development, I know what it took on this section. In fact, some jobs, if you want to get some jobs, they just give you some data structures questions. If you can scale it, then you'll get the job. If not, you're not going. So this is something that as a community, we need to like pay attention to this. All right. So what are your environments for Ethereum smart contract setup? If you're familiar with Node.js and NPN, awesome. So and you're familiar with how to install your node, awesome. Stuff. If you want more details, go to node.js.org and check out the documentation as well. So the NPN is always there. It's included with Node.js. After Node.js, you can install your NPN on your terminal. I'm not going to do a live coding here, but just to like introduce you guys, and then we'll see some hands-on tomorrow. Okay. Let's assume your nodes there. This is how you check your version to verify what version. And there's some, and this will also help in terms of what you're building. So always know the nodes. There's a lot of nodes, there are a lot of upgrades, and like NPN as well. This also helps too in the application. So we have a lot of editors out there as well. The code editor, this is like Visual Studio, VS. So simply, and a lot of us use VS Code, and it has extension for Solidity. So John Blanco was the one who designed this extension on the VS Code. So it's something that you need to explore, and I believe you guys are familiar with that. So if you're in your system, if you just type code, you write a version, it should be able to show you the version there. All right. For Truthful, you have Truthful. This is another framework. You have how to install, how to build. You're familiar with Truthful, and this is how to install it. npm install G global, then Truthful, and then install, and then start, debugging. You also have this is how it looks like, maybe like spinning up your first. You can make your directory, and then you enter into your directory, cd your directory, and then you initialize your directory. So this is how Truthful projects look like. The configuration of Truthful, you'll be familiar with the Truthful, config.js or Truthful.js. So, and you want to check the version, this is how it looks like. You have the Hadat, for some of you guys who are Hadat fans. So this is how it looks like. You install it, and you make your directory, you enter your directory, you call it up, and then you start. So, okay. Okay, all right. I've talked about the VS and how you enter. All right, so this is for the Hadat, and this is how you call. And for others, we have the Ganachi. You can install Ganachi. And you also need to install your MetaMask, because that's what you'll be interacting with. These days now, you also have different wallets. You have the Coinbase and so many of them as well. You also need to be familiar with Interscan. So you need to like have some API here or registering here. So let me just hold on. So for declaration, this is how the smart contract declarations look like. Let me hold on here for maybe if there's any questions, if I proceed again. Any question on the chat or something? Okay, if none,
Then on the chat, does anybody have a question? Please, you can just raise your hand and you'll be called upon.
Okay, so let's just move on. So this is how your contract encapsulates the entire code of a particular contract. I've shown you guys earlier for this. What's happening. Okay. Okay, let's just take a break and then come back in.
Okay, so of course, while our speaker is setting up his technical issue, okay, we have a question. What is the minimum system specifications to run smoothly as, let me get that message. There is a question from Dean, and he says, what is the minimum system specification to run smoothly as a developer on Ethereum blockchain? Okay, Dean, if I get you correctly, you're referring to your system, your personal computer specification, yes? Okay, yeah, awesome. So, yeah, of course, when writing, when interacting with the blockchain, of course, your device is, I think you need a RAM size of about 4 gig. I think 2 gig should also work depending on um, the number of applications running on your personal computer at that time. But most preferably, if you want a very smooth ride, you should go for a PC that has at least 4 gigabytes RAM to manage your memory effectively. Of course, I hope I answered your question. Yeah, all right, awesome. So, does any other person has any question? Okay, great, awesome. So generally today is an overview of account abstraction, and of course our lead is getting there. It's good to always start from the basis to explain it, because when you're talking about an account on the Ethereum system, right? So an account is just a way to interact with your blockchain using your private key, right? So if you have a private key, and of course that private key also would have a public key, which is an address of your account on the Ethereum EVM, the virtual machine, Ethereum virtual machine. So with your private key, you can actually do stuff on the blockchain. You can send transactions to the blockchain. You can, of course, retrieve data, information from the blockchain with your private key. So when we're talking about account on the blockchain, we're talking about a space where you can actually interact with the blockchain, right, and do stuff. So our speaker is back, so we'll just let him handle the floor. Please go ahead, sir.
Hey guys, so okay, I think I'm fine, right? Yeah, I think you answered the question, great. So, just a minute. Okay, so compact contract declarations. As I said, this is example, and each whatever you declare or whatever you're writing on Solidity has a version. So please, you need to take note of the version. As we get hands-on, you see different kind of logics here. This is a state variable, and it holds what state variable actually hold the persistent data of the contract. So variables can be accessed and modified by other function within the contract or external actors. So this is how it looks like. You have your int, signed int, and then you have your public and you have your variable there. what are functions? So functions are the behavior and the logic of smart contracts. So as a developer, you need to you play with your functions very well. That means what you want. As in, if you can be crafts, if you are very good with your crafts. So function is where you tell whatever you want your contract to do, and go. So the functions can have visibility modifiers. And what are the modifiers? We have the public, which you learned in your if you recall in the boot camp, the public, the external, the internal, private modifiers, and they can be called by other functional or external entities. So this is how it's like, and I shared events. So as I said, events use the log or broadcast. I think I've shared this earlier. So this is how it looks like. Even provide a way to notify external application or users about changes or important events in the contract. So this is how it looks like. So what about your constructor function? So construct function is a special function called only once when the contract is being deployed. So it is that you need to know that it is used to initialize state variables and performing any setup required during the deployment. So that's when you call it once. The constructor set the initial values of state variables and perform any necessary setups. So if you understand your structure of a smart contract, the fundamental of development, this component, the constructor function, collectively form the building blocks of solid. This is smart contract. So that's at the point of deployment, you play around this. So this is how it looks like at the constructor functions. Then this is like the Solidity compiler. What is Solidity compiler? It is so while compiling smart contracts, you need to be familiar with the Solidity compiler and the basis of compiling Solidity code. So the Solidity compiler, what is it? It's used to convert human readable to Solidity code into machine readable byte code that can be executed on the Ethereum virtual machines. Solidity code is typically saved on. You need to be familiar with the extension, the SOL extension, and the second one is the basis of compiling Solidity code. You can use the Solidity compiler through the command line or by integrating it into development frameworks like Truthful or Hard Hat. So you need to know that, and if you're saving the Solidity code in a file, you can be familiar. Your name and then the extension is the XOL. So when you see XOL, just know that it's a Solidity code and stuff like that. So to run the following command to compile, this is how it looks like. So the cat.bit is there. So if you want to output the byte code, the application binary interface, then the API. If you want to output that, if you want to output you optimize to enable the bytecode optimization. This is the codes and stuff like that. So these are some syntax, some stuff you'll be playing around with. So I'll show you how to compile your truthful. Once you this is how you compile it. As I'm using a truthful, it compiles the contract directory and generates corresponding artifact in the build. Okay, let's look at the artifact. What are the artifacts? That's the API and the bytecode. So the API is application binary interface. Note that the API is a JSON representation of the contract interface. It defines the method and data structure that can be accessed and interact with by an external entity. So the API is very crucial for interacting with a deployed contract, allowing external applications to understand how to communicate with the contract. So get to know this, and so this is like an example of an API. It's quite some length code, and then like this. Okay, you have your name, let's play around with all this JSON stuff. Okay, so that's for the API. Then look at the bytecode. The bytecode is the machine readable representation of the compiled contract logic. It's the code that is deployed on the Ethereum blockchain. So it's actually a machine, what's readable representation of the compiled logics. So this is how it looks like, the bytecode, OX, and then so if you understand the compilation process and the resulting artifacts, it is essential for deploying and interacting with smart contract on the Ethereum blockchain. These artifacts play a very crucial role in the deployment and integration of contract within the Ethereum ecosystem. So you just understand this, you don't need to like go deep or just have an understanding on this. So deploy your Ethereum testnet. So yeah, we're going to introduce it to testnets, Ropsten, Rickenbacker, Hoover. The testnet and Ethereum networks specifically designed for testing and deployment purposes. So this is like where you have your fake, do I call it fake or just call it like a test currencies? Just have this your virtual your simulation as if you're on the main net, but you're not in the main net. Deploy whatever you do. So what, and that's where you can check your errors, check whatever it is, before you push it to the main net. Right, they mimic the functionality of the Ethereum mainnet, but uses the test ether, to do this, to avoid the retransaction and cost, for instance. The common testnet on the Ethereum listings are Ropsten, Brickbell, Coleman. And the Ropsten is a proof of work testnet, and transactions are mined similar to the Ethereum mainnet. It uses test ether obtained from the test Ropsten faucets. Rickebell was Rickebell as well. Okay. Okay. I think I'm going to stop here. I'm going to stop here and then take some questions, and then we'll continue tomorrow. Okay, any questions from now? Let me see.
There was another question. Osinachi is asking if the slides will be shared. I think that's the next. After DNAX, Osinachi is asking for access to the slides.
Okay, sure. Sure. The slide will be shared. Are you guys on the Discord? So we're gonna create a channel for that and drop the slide there. So yeah, I think that's what we'll do there. If you're on the Discord, and if you're not, you could just request then add you guys there.
Great, awesome. Of course, that was very, very refreshing. Of course, all the components that make up of the smart contract, and of course, by tomorrow, we'll get our hands on, of course, the first part of actually building account abstraction from scratch. But before then, of course, please feel free to ask questions, and of course, for stuff you are not cleared about, it's always good to ask so that you get clarification on the stuff. So having said that, I will also still leave the floor open for any questions. But in the absence of questions, basically, of course, the links for tomorrow's session, of course, will be emailed to us. And tomorrow will be a hands-on. We would actually be writing code from scratch, seeing how it works, and actually looking at all the components that have been shared with us today, and of course, how they are used or how they are combined to interact with the Ethereum virtual machine. And of course, these are very interesting concepts in blockchain, because prior to account abstraction, right? So for those that build decentralized applications, and of course those that use these dApps rather, there is always that a little how do I say this, like if a user sends a transaction, the user has to wait for some time, right? So imagine going to a website and then probably to verify your wallet, right? You need to sign it. Then probably you need to make some payment, or you need to send a transaction that it actually has nothing to do with payment. Let's just say to update the state of the blockchain, right, of the Ethereum virtual machine. Now, the concept of account abstraction actually allows such a way that it makes it very easy and feasible for this to happen, such that the user is not prompted every time the user tries to make a change to the state of the block of the EVM. So actually, the concept of account abstraction handles it such that even another external wallet, right? A smart wallet, a smart account can actually pay gas fees on behalf of the user, right? So you are sending transactions, but another person is paying another account. In this case, the smart account is paying for your gas, right? So these are some of the many benefits of account abstraction. And of course, we'll look at it hands-on tomorrow and next. So in the absence of any question, I don't know if our speaker has any last words.
Okay, guys. So great. The materials will be shared, so you just go through it, and then in the materials you'll be able to like go through deploying on the Ethereum testnet. You look at some of the codes on Truffle deployment, how to run it. Likewise, Hardhat deployment, you see some codes there. You get used to the transaction hash, the contract address. You also learn. We also share on interacting with deployed contracts. Contract address, the API. You also introduce to the JavaScript libraries, and how to install your Web3.js, how to use it, your Ether.js as well, and some function as well, retrieving data as well, and deploying the mainnet as well. We'll just share some little info there, but not really deep. And then you look at some consideration for deploying the Ethereum mainnet. You look at truth testing before deploying, security audit. You look at some gas costing, understanding the transaction fees. You look at gas price strategies. You look at network congestion, private keys, security, confirmation times. You learn Ether scale, verifications, and your documentation as well. So these are some of those stuff you're going to see on the material as well. So we've spent a lot of time, so just trying to cut short and then so have a nice day. So it's great. Please amplify this. Reach out to as many as you can to join these sessions. We're bringing a whole lot. Yeah. So if you guys in Lagos, please join us on Saturday. Tell your friends. Let's fill the house, guys.
Great, awesome. Thank you very much, our speaker, Mr. Enoch. Of course, we appreciate you making our time to actually, of course, share with us from your wealth of knowledge. And for us that participated in this session, thank you also for making out the time. And of course, tomorrow is another great day where we'll be looking deeper into this concept. And of course, please do make yourself available. And of course, invite one or two people to also share in this, right? So remember, in the blockchain, the community is everything, right? So we learn together, we earn together, of course, we grow together. So, of course, it's nice having all of us here. And please let's, of course, make ourselves available for the other parts of this series. And of course, it always gets interesting. For those, Osinachi, you are here. I think I saw Dean a while ago. You recall that in the bootcamp, it always gets better as we go. So of course, as we dive deeper into the concepts with some hands-on, we'll get better understanding. Of course, we can fully interact with the blockchain. Yeah, George. Yeah, thank you very much, guys, and do have a wonderful evening. See you guys tomorrow. Do keep to time, and of course, remember to invite 1 or 2 people. Thank you very much. All right. Good night, guys.
Thank you. Good night.